All right, now we're gonna look at how to balance redox equation in basic solution. Okay, let's first find the oxidation number for each element here. O is always gonna be -2, and now there's 4 of them, and it has to equal -1, right? So this must be +7. I here, oops, I will be -1 here. O is -2, and there's 4 of it, so that's -4, and has to equal 0, so this should be +4. I2, that's going to be 0. Now, let's look at Mn. It's going from +7 to +4. So that's becoming more positive. I mean, sorry, that's becoming more negative, right? It's going from a big positive number to a small positive number. So it must be being reduced because it's becoming more negative. How about O? O is the same, -2 to -2. I is becoming more positive. It's going from -1 to 0, so it must be oxidized. Okay, write the half reaction. All right, let's look at what's being oxidized. It is I minus becoming I2. And then for reduction, it's MnO4 minus becoming MnO2 solid. Yeah. All right. Balance the atoms other than O and H. So this one, since there's 2I on the right, this should be 2I on the left. And this one, Mn and Mn, they're balanced already. Number 3, balance the oxygens by adding H2O. All right, so there's 4 O's on the left and only 2 on the right. So we must add 2 more O's by adding 2 H2O. Okay, balance the hydrogens by adding H plus. All right, so since we added 2 H2O here, we must add, oops. Oh, I'm sorry. Whatever. Okay. So we must add 4H plus here, right? Because there's 4H on the right. Okay. So we just did that. Add OH on both sides for each H plus added. Now we just added 4H plus here, right? So what we need to do, I'm gonna move this to the left. What we need to do is we need to add 4OH minus on both sides. Why do we do that? Well, it's because this is a basic solution. So we have to write it in terms of OH minus and show that it is a basic reaction, basic solution. So we add OH. And when you add H plus and OH minus together, when they meet together, they actually become 4H2O, right? Okay, and then what happens is that since there's 2H2O here and 4H2O there, this becomes 2H2O, and we can just get rid of the H2O on the right. Okay, so that's how the reaction, so that's step 5, right? We added OH on both sides. Balance the charges by adding electrons. Let's look at the first one. There's 2 minus here and 0 here. So we add 2 electrons on the right. For this one, there is -1, right? Total charge here is -1. And here we have 4 minus, right? From the OH. We have 4 minus. So what we need is, we need to add 3 minus here. So there should be +3 electrons right here. Right, let me just write that inside this equation. Okay, there's 3 electrons here, and the charges are balanced now. Okay, and now we need to make the number of electrons equal and add their reactions. Now here, there's 2 electrons here, right? And there's 3 electrons here. How should we balance them? We can do that by multiplying 3 here and multiplying this whole thing by 2, right? So let's rewrite the whole thing. Okay, let's write this one over here. So that's going to be 6i minus. It's going to be 3i2 plus 6e minus right here. And then this one is going to be, we multiply 2 on everything. So 2MnO4 minus. Now I just said we're gonna use this one, right? We just made 4H plus and OH minus into H2O. So that's gonna be 4H2O multiplying 2 here plus 6 electrons. It's going to be 2MnO2 plus 8OH minus. Okay, now we add them together, then we add these together. And if we do that, we get the electrons cancel out. So the final answer we get 6i minus plus 2 MnO4 minus plus 4H2O becomes 3i2 plus 2 MnO2 plus 8OH minus. And of course, we need to add all the states here. So MnO4 is aqueous. I is also aqueous. H2O is liquid. I2 was a gas. Oh, sorry. I2 was aqueous. MnO2 was a solid. Okay. So a solid is being formed. OH minus is aqueous. So that's it. The equation is now balanced. We can check it by looking at the I's. They're both 6, 2 Mn's, 8 O's for plus 4, so that's going to be 12 O's. In this case, there's 8 O's here and then 4 O's, so that is 12 O's here. 8H. 8H. Okay, so the equation is balanced. All right, so that's how we balance a redox equation in basic solution.